word problems, right? So we're going to do a lot of word problems. Don't fear them. You're going to have your calculator to help you out every time. But this is a whole nother ball game when it comes to word problems, especially when it comes to the domain and range. So far, we considered all four quadrants when we're doing word problems. I'm going to say this again, 90% of the time you stick to quadrant one. 90% of the time. There's some exceptions, and we won't discuss them today. Today we're just going to get you introduced to the topic, right? Okay, so if you have a highlighter, page 32 if you're still looking, word problems. When sketching the graph of a quadratic function within a context, that means word problems. Contextual means there's a text surrounding it. Yeah, you must label the x-axis with words and with units. Okay, so now it's not just going to be x and y, it's going to be something else. Okay, can you see all right there? It's a little bit right. So for example, time, not just time, what is it measured in? Hours? Is it seconds? Minutes? What is it, right? So you have to have both if you want to get full marks for a graph. Just like before, by finding you find the vertex, start just like before. We want the vertex and the intercepts. Those are very important to us. Even in grade 12, those are going to be the important points you want to find. This will give you a good idea of what scale to use when asked to graph, right? And these are going to be important in other ways as well. Most of the time, variables will need to be positive. Most of the time, variables are positive. I'm going to say that. The majority of the graphs will be limited to quadrant one. So I'm giving you an example here. So not only will you be given the equation, there's a context, right? So this is the context where h of t represents the height in feet and t represents the time in seconds. What that is telling you right there, from now on, you always recall that this was always your y, right? The y is always on the left side, always. We're never going to trick you that way. And these are essentially your x variables, right? That's your x. But right now, x is replaced with t, the variable t, which stands for time. Okay? So what this context is telling you that x is what, and for me right now, it's time, right? Look at the right side of the equation. T is found there. So everything is going to be time followed by height. Okay, that's what it's saying. Time is x, height is your y variable. So immediately you will say, okay, my x-axis is going to be time in seconds, and my y-axis is going to be height in this case, feet. It could be yards, feet, inches, centimeters, you name it. Right? So boom, this context gave me a lot of information, and I always refer back to the equation, right? It's like, oh, this is y, and these variables must be, right? The x is on the x-axis, of course. And so there's important points. You can tell you've got the y-intercept here. The y-intercept in this case means something specific. That is the initial height. Okay. Initial height. So we actually have a name for it within the context. It's like, where does this projectile, where does it start off? It's not on the ground, it's off the ground. So we would refer to it as 0 height. When time is equal to 0 at the very beginning, there is a certain height we have at that point. Then, so the ball is up, like it's thrown up in this case, and then we reach the highest point, which we call vertex, correct? So that's our vertex. And it also gives us time and height, but not just any height. This is the maximum height achieved, right? I'll put this in quotations. Gives the maximum height after X seconds. We're going to be able to find that point specifically. We don't know what the time is, but we do know at the beginning it's 0. Here we don't know yet. We'll have to find that as we go. So y-intercept, vertex, and here you have the x-intercept. And you wonder why we're not worrying about the other x-intercept over here on the negatives? Because time can't be negative, right? So for us, the story starts at the y-axis. We do not worry about this part here, okay? So keep that in mind. So this x-intercept is, for us, I will put that down, time, the object remains airborne. Page 32. Time, the object remains airborne. And we know that we can say that there will be a certain time, we don't know what it is, and we know that our height, or our height at that point will be 0, right? We know that it's hitting the ground, so the height above ground would be 0. Hits the ground, let's put that down here, hits the ground. It could be hitting the surface of the water, like a diver, let's say, dives right in. So it would be like how long did that diver remain airborne before hitting the surface of the water? But it's definitely the x-axis here with respect to the x-axis. So we've got y-intercept, vertex, x-intercept, just like before, but now they mean something within the context. Let's keep going. This is the domain and range is going to be different now. Very rarely will you have infinity show up, okay? So for the domain, when it comes to set notation, quite often it'll go like this. From 0, in this case the variable is t, all the way to where the action ends. And quite often that is the x-intercept. Quite often. I wish I could give you just a magic formula to always come up with the domain, but I can't. So this would be set notation. When you want interval notation, you would just go like this, 0 to whatever the x-intercept is. And usually they're both included. Okay. For my range, it's the acceptable y values. So it will be like this. I'll write it a little different. Lowest y And in this case, we have to use h of t all the way to the y of the vertex. And right now, this seems very, very odd, but just write it down for now. The lowest y value you can possibly achieve in this story all the way to the y value of the vertex, which in this case would have been the highest y value. So again, in interval notation, we would go lowest y all the way to y of the vertex. I will say this in the bottom here. Lowest y, okay, is usually 0. Usually, emphasis on usually. That means that there could be exceptions. So you're going to have to pay attention to what's happening in the story. Come up with that. And I want to do a couple, and then the rest will be homework for you. Just doing the domain and range today, that's all. It's going to take you a couple minutes, that's it. So let's go to page 33. And I have various stories here for you. Various stories. So let's do the domain and range for the first one. Domain and range. And I hope this is going to help you, but I'm going to use, for domain, I'm going to use pink. So I'm going to say what x values are acceptable. And in this case, the story starts here and goes all the way to here. And this point right here is called the origin, right? The origin is 0, 0. So you can actually put down 0, 0 there. And for range, I'm going to use green. So the range is the acceptable y value. So it goes from here all the way to here, right? This kind of matches it. I don't know if you want to make a line here and call this 450, right? It does give us a coordinate of 450. And if you're looking at the domain, you're just looking at the x values. So I'm going to go to the origin, to this point, and it goes from 0 to 450. So if you want to use set notation, it goes 0. I'm going to use lowercase l for length. Okay, I'm going to put a lowercase l here so you know what happened. All the way to 450. That's not my preferred one though, because you need to use a variable. This is the one I prefer. I'm going to go from 0 to 450. Like that. That's interval notation. That's the one I prefer. For the range, watch this. We're going from 0. Let's make a line up here. Oh man. Can I just finish this? I'm going to try to hurry. 0, you're going from 0 to 50,000. So 0, let's use capital A for area, okay? To 50,000. That's my bad, guys. Or 0 to 50,000 like this. Can you do the rest for homework just on page 33? I think there's one more on 34. That's your homework. I'll go over it with you tomorrow.